one of the benefits of what Neuralink is doing is investing a lot of money in the private sector, right? There's a lot of red tape, and in the private sector, a lot of that's just gone.
Hey everybody, welcome back to NeurosciQ, the best place on YouTube to increase your neuroscience IQ. Today we are joined by Dr. Anna Wexler from UPenn. She's assistant professor in the Department of Medical Ethics and Health Policy at UPenn's Perelman School of Medicine, where she also runs the Wexler Lab. She focuses on ethical, legal, and social issues surrounding emerging technology, neurotech, and DIY, and direct-to-consumer medicine and science. We are excited to have her join us today to talk about her areas of expertise. Welcome to the channel, Anna. Thanks so much for joining us.
Thanks for having me.
Before we get started, I personally think it's a very intriguing niche that you're focusing on. And a couple of weeks ago, Phidias and I actually had an episode where we discussed why we got interested in neuroscience. So on that note, could you tell us a little bit about what got you interested in your field? How did you decide to get into ethics, and what intrigued you to get into neurotech?
I think that's my favorite question, is hearing people's answers to that question. So I guess I would say I've always been interested in the brain since I was a teenager. And so I majored in brain and cognitive science as an undergrad. And I thought I wanted to be a neuroscientist. And so I did all this work in research labs to sort of build up my, little CV at the time, right? I was still very young, just to be I wanted to be a neuroscientist. And at some point I realized, that the bench work of doing neuroscience, the day-to-day, wasn't something that held my fascination as much as the larger questions like surrounding the implications of neurotechnology, what it would mean for society and things like that. And so that actually pointed me in the direction of science writing, because there I found that I could ask scientists whatever questions I wanted to ask them and get the answers to those big questions. And so I love doing that. I did that for a number of years after I graduated. At some point, I decided that I wanted to do my own research projects, because when you're writing about others, you're writing about other people's work. And at some point I was like, I want to do my own projects. So I applied to do a PhD at MIT in history, anthropology, science, technology, and society. It's one of their programs. It's interdisciplinary, basically just to study the implications of brain-computer interfaces. When I started the PhD, it turned out that, I realized that there wasn't a lot to focus on. It was a little too futuristic. So I ended up doing my PhD studying people who stimulate their own brains, the do-it-yourself brain stimulation movement. And then from there, I found that people who were writing about this field were actually in ethics and in something called neuroethics. And so I sort of found my field where I'm in now through that. And so people are writing about the ethical, legal, and social implications of advances in neuroscience. And so that's the group of people doing that are usually referred to as neuroethicists. And so that's kind of the route that I took to get where I am today.
Yeah, really cool. I always like to hear about people's routes to where they are and how they sometimes just kind of fall into things, even if it wasn't their initial plan. Now you mentioned neuroethicists in your answer, and if you had to define what a neuroethicist is, what would you, how would you define it?
So there is no one definition, and the definition of what neuroethics is something that people disagree upon. But I would say that most of the field are people who study the ethical, legal, and social implications of advances in neuroscience and neurotechnology. And so what that means is you could have people really coming from the philosophical standpoint and just thinking, like from a theoretical perspective, so sort of divorced from what's going on in the real world, like what should we do in certain cases. There's people who study research ethics related to neurotech. So, the kinds of protections that we should have for human subjects, especially in things like first in human trials, right? If there's a new brain-computer interface or a new implant that you want to put into someone's head, what are the ethical issues surrounding those and how do you navigate those, right? And And then there's people who look at some of the regulatory and legal issues. They're focused on legal. And then there's a lot of sociological work. So looking at, people's attitudes towards neurotechnology or interviewing people involved in the neurotechnology space, about what they see for the future and things like that. So that's sort of what people are and what a lot of the work in neuroethics focuses on.
I know that's really great. I know for me, thinking about some of these ideas, especially in the context of COVID, where we see different social classes, getting different kind of preferential treatment from kind of work from home measures and whatnot, and it's really created a divide rather than equalizing humanity. When it comes to neuroethics, I mean, aside from the limitations which we'll discuss shortly, the potential that people think about with neurotechnology is, the brain-computer interface, the ability to store limitless amounts of data in your brain, the ability to control objects with your thought, bearing these kind of potential future implications in mind. Do you see these types of technologies as technologies that will unify people or create further divide with the elite getting access to kind of the most cutting edge technologies and leaving perhaps people with less access behind?
I think that's a fantastic question. And I agree that the pandemic has really crystallized or made even more clear existing divides and really just shown us in a short period of time very clearly how they play out. I think it depends on the neurotechnology itself, right? So I think I've seen people argue it both ways, right? So you could say, look, if there's some cheap sort of cognitive enhancer that'll be available to people who may not have access to other sorts of enhancements, then that has the potential to decrease the divide. I've seen people argue it the other way and say that, these devices and technologies are likely to be expensive. They're likely to be only available to a privileged few, and it's just going to exacerbate our existing and current inequalities. And so really you could argue both sides of the same coin there. My personal view is that I don't think that they are going to solve any of the inequalities. I wish they would. I wish I was more optimistic. I would say, I think what we've seen, this is something that's been known for a long time, but really apparent this past year, is that the structural inequalities in our society run really, really deep, and that these are extremely complex issues. And I don't think that a technology, like just a single technology, or even a set of technologies or a class of technologies, is going to bridge that divide, even though I wish it would, right? So I guess I'm on the more, unfortunately, more pessimistic side, that I think it'll probably, if these technologies are effective, right, and they do work and enhance our cognition or give us some additional capabilities in some way, I think it's most likely that they're going to just increase the divide, unfortunately.
Yeah, that's a good point. Go ahead, Christina. Sorry.
That's okay. With that being said, on the note where it could be increasing the divide, what about when we think about healthy individuals versus people with maybe neurocognitive disorders or some sort of other disability? I know in your paper you said that you questioned whether it would be practical for healthy individuals to use their attention to control a computer. But what are your thoughts on individuals with neurological disorders using technology like BrainGate to help them function in society? Is it feasible to say that this technology might help bring them to the level of functioning that we are at?
So I think BrainGate and BCIs for like assistive communication devices, those are super exciting. And like, if those can work, that would be fantastic for, the set of people who can't communicate currently. So I would say I'm excited about those. I think they're complicated, and there's a lot of technological challenges. I think one of the benefits of what Neuralink is doing is investing a lot of money in the private sector. So in academia and institutional settings, right? There's a lot of red tape, when you get grant funded, right? Everything's just slow and there's a lot of bureaucracy and red tape. And in the private sector, a lot of that's just gone, essentially, right? There's just pools of money to hire people and you can really attract talent. So I think what we're seeing with Neuralink is that the technical engineering advances that they've been making are pretty significant. They're not demonstrating, or so far from what we've seen, they haven't demonstrated anything that, that what they've demonstrated, has been done before, like a long time ago.
Mhm.
But the technological advances that seem to be that appear in the videos anyway of what they're showing, all they've released is like a little blog post, like a little video. Those seem to be significant. And so it's the technical challenges, I think, that have prevented the technology from really making its way from the laboratory, right? Where so far it's been mostly people who've been like wired to a device, training for hours and hours, and the communication has been very slow. And if you can get better signals, clearer signals, you can make that wireless, reduce the training time. So I think there's a lot of potential there on the medical device side, right, for assistive technology. So I think that's where they potentially could have a major impact.
Yeah, I think that's exciting, and I know when we post neurotech videos, we sometimes get comments from patients that obviously had some sort of debilitating unfortunate circumstance, and they're looking for answers. So I think we all hope, regardless of our optimism or skepticism, that at least for that type of application, these devices are made available, but not only available, but at a kind of price point where at least people with that have been debilitated by strokes or other neurodegenerative diseases can truly benefit from them. What about for the average consumer? I know that you've expressed some doubts about application of these technologies for augmenting neurocognitive function from outside of the kind of diseased or debilitated state. What do you think? What do you think would you need to see or marketed for you to go into a surgery room and get one of these devices implanted in your brain?
So I will say that's an excellent question. And that's the first time I've been asked a question like that. And it's a really interesting one to think about, right? Like what, for each of us, right? Like what would the risk benefit trade-off be for us to want to undergo neurosurgery? And so, I think about the technologies that I use now where I give up something. And so mostly in order of, in favor of convenience. So I have, Amazon Alexa, I have Alexa in my home, I have a Ring doorbell. I'm very much aware of all the data and privacy concerns, but it's just so convenient that I trade off my privacy issues for that sort of convenience. And so I don't think I would get neurosurgery to have something be a little more convenient. I also don't think I would get neurosurgery if it made me type a little faster, right? Neurosurgery is it's a big deal. And I would say the long-term health consequences of having something like that implanted, whatever the ultimate end product is, right? It's really unknown. So, I guess the short answer is, I don't know. I don't even know what use they're envisioning, right? But it wouldn't just be, it wouldn't be something small. Just mere convenience wouldn't do it for me personally, or even like sped up communication with my computer. So yeah, I'm not sure. It's also interesting to think about the cosmetic surgery analogy or elective surgery. So what risk people are willing to take in order to look better, right? Just purely elective surgery. So LASIK, so you don't have to wear glasses after you get LASIK surgery. There's lots of other cosmetic surgeries. That's not neurosurgery, right? So there's a difference there. I think that's just an added level of risk that you'd be taking. But I don't know. The short answer is I don't know. But it's a good question.
Yeah. it's a difficult question to answer too. And I think just the fact that neurosurgery is so invasive makes it something that not a lot of people would lean towards just to improve their day-to-day convenience. But what about things that are less invasive? What are your thoughts on perhaps companies like Neurable that are developing dry EEG wearable devices? Oops, sorry, or other companies developing direct-to-consumer wearables?
So non-invasive, that eliminates that whole risk thing, right? Like
Mhm.
it's just gone. I mean, pretty much, unless it's a stimulation device, in which case that adds some additional risk. But let's say we're just talking about like some kind of imaging or recording device, right? That whole physical risk, safety risk is out of the equation, right? So for me, I don't think it would take that much to get me to wear it, but it would have to add some value. And so one thing I write in the piece in Stat is that consumers have been very wary about adopting like things that go on their heads, even helmets, at least in the US, right? People don't want to wear helmets. People don't want to wear things on their head. We've had Google Glass. We've had actually, this consumer wearable neuro device, world has been around for at least 15 years now. And none of the devices have taken off. And I don't think that the funny looking thing on your head is the only reason, but I think there's something there that's been understated or perhaps not discussed enough, because I think that's a big barrier. So the other point to mention about the consumer EEG is again, that's a market. Consumer EEG specifically has been a market that's been around since about 2005, 2007, something like that, right? So these devices have been sold. Initially, they were sold with marketing claims for the control of objects. They weren't very reliable. So it's like a party trick a little bit. And then, you can't actually like reliably control the device with these consumer EEGs at the moment. And then later today they're marketed for wellness applications. So you're supposed to be able to improve your mental health by having access to your EEG signal. So I think with Neurable, my question is, so I wouldn't feel any, there's no risk to take, but the question is, what value is the EEG data adding?
Mhm.
What's it getting me? And is that going to make me want to wear a helmet or a headset? So I think that's an open question and one that I haven't actually seen answered very clearly.
Would you be worried about companies collecting data from the EEG devices, just like, Amazon Alexa could be reporting data to the company? Is that something that people should be concerned about?
I mean, maybe yes, in the sense that, I'm concerned about all kinds of data that are being recorded, but like Alexa, my GPS, my phone, my browsing history. There are companies that track, like, they have cookies on, their websites. They track where your cursor is on the screen, how much time you spend on the screen. I mean, they create whole profiles of you. So in my mind, that data that I'm giving off right now that is not well protected at all by existing privacy regulations and protections, that is very concerning to me. And so when I think about what I'm concerned about when it comes to privacy, like that is more revealing and more concerning. It's possible that the EEG one day will be able to look at it and, get more information out of it. I mean, I don't think the EEG is very revealing at the moment. So right now, no, I'm not that concerned about EEG data, but I am concerned about privacy. I think the other privacy questions deserve more of our attention than a brain data that may in the future reveal something.
Yeah, I know we're experimenting with some of these devices, and one thing we're trying to elicit is the so-called P300 response, which is kind of from what I understand, a measure of novelty when your brain sees something that it's surprised to see. And I guess that's very powerful from a marketing point of view. If you could, if we imagine a world where we're all wearing one of these devices on our head, as silly as we would look, I wonder if the ability of these companies to know when they have our full attention, or fine tune TV ads to elicit these responses, will make advertising even more difficult to to get away from. I know when I see something, when Amazon shows me something enough times, I'm like, okay, I'm gonna buy it. I need it. I wonder, if they know when I'm at my most kind of intrigued, period during the day. I wonder if that's going to get me to click buy at an earlier rate.
So there actually is a whole world of consumer neuromarketing. There's a whole world of companies just selling measurements with EEG for marketing abilities. If you like search for neuromarketing or consumer EEG marketing or consumer neurotechnology, a lot of times this comes up. And so it's actually interesting. I just connected with somebody recently who was in the space and was on a panel with people in that world. And so, they've been doing that for a while. They also have traditional measures of engagement that are also useful. So where does your eye gaze go? And what do you rate on a survey after you look at something? What's your galvanic skin response, right? And so from what I've heard in that space, and I would say, again, I'm not really in it, is that they're plagued. I think a lot of the companies have the same issues of what to do with this EEG data. Like, what's your metric of attention or engagement or arousal, and what are you comparing that to? And so I think that's been the struggle there. I've heard that they often assign it like a number based on these proprietary algorithms. So you'll get like a 9 for engagement, but the company won't tell you what that 9 is or how it's created or things like that. So I think the issues there are, again, the fidelity of the data and how that data is being interpreted to show things like arousal or engagement. So I think in theory it's interesting and it's being used. I guess I don't know if it's lived up to all the hopes that some marketers had for it.
Yeah, I know something we've noticed even just as we began playing around with them is that when we build classifiers for at least the EEG devices with 4 or 6 probes, they actually cluster based on the individual rather than the actual state, whether you're trying to meditate or watch some stimulating video. And I don't know, we're still trying to figure out if that's the user's not putting it on properly. They have a specific way that they're kind of using the device, which I think is one of the limitations that we've seen, is that it's great to have these consumer grade devices, but if people are wearing them slightly different, the electrical activity is going to be very hard to compare across large populations of people that may wear them slightly different, because it's not like a heartbeat where you're measuring on your watch or a specific artery. It's your whole brain's active. So I think that's one limitation that we've seen, but where we're hoping things can be overcome is if you can collect the same data on the same individual and presumably they're wearing it the same way. I wonder if continuous data gives you a chance to actually create very clean, personalized data for that individual to really understand when they're engaged, and overcome some of these kind of signal to noise problems that probably are plaguing a lot of these devices.
Mm-hmm. I think that's interesting. On the devices that you're using, are you looking at the raw EEG data, or are they like spitting out like their measure of engagement as like a number?
Oh no, we use the raw data. We don't use the numbers that they spit out, because we're trying to develop our own kind of classifiers for specific I guess actions. We want to understand, can we predict behavior based on someone's brain activity? Mm-hmm. So yeah, it's there's definitely a lot of question marks. I know when we began and kind of embarked in this field, it seemed like everything was kind of figured out, and we would kind of hit the ground running. But it seems it's still very much in its infancy, and what devices are suitable and which are not, I think are still unclear to us at least.
And also depends if you're placing them on people in the lab, or like you say, they're going out into the world and maybe putting them on themselves, taking them off, right? That you might get different measurements.
Yeah, I mean, I think the transformative thing from our perspective is just the way the scalability. If consumers can wear these reliably and you can collect data at scale, I wonder if that's the kind of solution to the problem, or it could create a bigger mess. If they are so sensitive to where they're placed on maybe there's a reason why these studies are done in very controlled settings in only a few labs around the world, is that location matters. So it's interesting to see how these what solutions will come about to solve these.
Yeah, and I mean there does seem to be a lot of interesting work invested in the space now, right? So whether they will, I don't know whether they will find a solution, but there's definitely people working on figuring out solutions, or trying to anyway.
Yeah, it should be an interesting few years. I guess on that note too, given the time you've had to digest some of these kind of applications, do you think there is a home run application right now where if someone said, I'm thinking of getting one of these devices for X, and is there a solution to X for you that you would say, yeah, I would definitely get that device for this application? Is there such a thing, or you think we're still not there yet?
So I would say the most exciting thing for me is not in the EEG space. So if someone was saying, oh, this device is marketing itself for wellness or for meditation, that's not the home run application in my mind. I'm talking about the EEG devices. Probably the most exciting thing I've seen in this space is a company called Control Labs that was acquired by Facebook. They're loosely marketing themselves as a BCI, although they've sort of moved a brain computer interface. They sort of moved away from that language a little bit, but they were acquired by Facebook. And what they said, it was essentially like, the brain is too complicated. We're not going to start with the brain. We're going to go to the peripheral nervous system. And so they do EMG. And so they're measuring, they're developing a wristband of sorts to pick up the electrical impulses in the wrist and to pick up intentions to move your fingers. And so they were acquired by Facebook. Facebook just released a video in the last month, a few weeks ago, maybe, showing off a demo of some of the technology. I haven't seen the technology, I haven't seen it myself. So again, I can't verify the demo or anything. But what they have seems to be smart, just from the perspective of what I write in my piece, right? So I mean, it's very hard to get signals that are very clear, have high fidelity, right, from outside the brain. And then to actually find a marketable use for whatever you're capturing, right? And so they're using this, their intention seems to be to use this for control. And again, not going into the brain, right? Just the peripheral nervous system. And so the signals seem to be much cleaner, and it seems like they're a lot closer relative to all the other products that I've seen that are going non-invasively, trying to measure something from the brain. And so in one of their demos, they actually have somebody typing on a an Air keyboard. There is no keyboard, but because their demo, again, haven't verified this, right? But if you can decode intentions to move there and you could figure out where people are in space, then in theory, you could actually interact with the machine, type on a fake keyboard or Air keyboard, whatever, a lot faster than you would on a computer. And that also seems to get away from another issue that I brought up in my piece, which was, if you have to really think about, if you have to use your focused brain power to control an object or a device, right, is that going to add any value to a healthy individual? Whereas this seems to be, again, just tapping into our fingers and trying to basically make communication with the computer a lot faster. because there's no, I mean, we communicate with our computers right now through our fingers mostly, sometimes through voice, right? But texting or typing, it's through our fingers. There's no reason why it has to be this way, right? So I think for me, that's, you know, I don't know if that's a BCI, but it's some kind of BCI-ish device, and that's the one that's I've seen. I've thought, I think that one looks pretty exciting and actually potentially feasible. So.
I don't want to date myself, and I forget what the movie was called, but when I was growing up, there was a movie of I don't know if it was called The Wizard, where there was this kid who was really good at playing video games, and he would go compete at the kind of international level, and then there was this super rich kid who was also really good, and he came in with a briefcase and he opened it, and there was this thing called the Nintendo Power Glove. And the guy had one of those conventional joysticks, and this super rich futuristic kid had put on this kind of power glove, and kind of like what you said, like he was controlling the race car with his glove, and everyone was just blown away. They're like, oh, it's the power glove. And it was but it sounds like I just remember it, the way you're describing it, so that's really cool to see.
You can think about a glove too. Yeah, like there's no reason why you have to go into I mean, I'm sure this company has a reason why they're going to the muscles, right? But even that, right? There's different ways that we could communicate with our machines that are faster than the way we communicate now. And that's also, I mean, you could easily just control objects with it, that same thing, using the same thing. So I should also just make very clear, I have no conflicts of interest here. I don't consult for any of these companies. I don't work for them, so.
No sponsorships.
No sponsorships, no. Yeah. Okay.
I wanted to also ask about something that you mentioned in one of your other papers. Just, how recently with the whole hub around Elon Musk's progress with Neuralink, and you mentioned the blog post earlier where everyone was really surprised by the fact that a monkey could control a computer with its mind, and kind of like you, how you said this technology has been around for a while. I was eating dinner and my sister was like, oh my God, did you see what Elon Musk did? And I was like, yeah, people have been doing that for a while. And she was like, what do you mean? But anyway, you mentioned how ethically we might not have to worry about people reading our minds. And in one of your other papers, you wrote that the most serious problem with the current DTC neurotechnology is the false and exaggerated claims about capabilities that such devices offer consumers. So other than this fact that we might not have to worry about somebody going in and tapping our brain waves, what are some more realistic issues that might come to light with the technology?
So first I'll say that it's like, I'm not a researcher who's been studying brain-computer interfaces my whole life, but you can imagine how a researcher who's devoted his or her whole life to studying that felt when they hear it. Because I mean, a lot of people are hearing about BCIs for the first time, right? And so, there's people who've devoted their lives to like advancing that field forward, and they're like, but in terms of the ethical concerns, so the way I like to think about them is divided in time. So what do we think are concerns now? Because there are concerns right now. What are concerns on the horizon, like near term, maybe 5 to 10 years, something like that? And then what are our future concerns? And so thinking of it in that framework just helps. When it comes to false and misleading claims, I think that's a concern right now, because I mean, even with EEG BCIs that are marketing their products to consumers, they're marketing them with all kinds of claims that really have not been well validated or at all validated. So definitely misleading claims is another one, is one that I think is a concern now. In a different way, I think Elon Musk's recently tweeted about that his technology may, forgetting the exact wording that he used, may, for example, give paraplegics the ability to walk again. And, on the one hand, he's not selling anything right now. So there's no, nobody can buy anything that he's selling. So it's different from the companies that are marketing a product and saying, here's a business transaction. I'm making a claim, you're paying for this product. And, so it doesn't go to that level, but there is something different about when he goes into the medical space and makes claims like that are right. So, and I should say also that even taking a step back, right, that a monkey playing Pong is very different from giving somebody the ability to walk again. Those are like, those are worlds apart in complexity and what's at least feasibility and what's been demonstrated, right? And so I guess that kind of tweet is not really a false or misleading claim in the sense that a company is making it. I think it's more something along the lines of false hope. And if you look at all the comments to that tweet, all the responses, they're from people who, have suffered like pretty serious spinal cord injuries, and they're really excited and they're really hopeful that he's going to solve their problems. And maybe he will in like 30 years, but that's not that Pong is not translating to the ability to walk again. So those are the things I see as an issue now. Another issue, so I would say on the midterm, like looking ahead, and even a little bit now, one interesting ethical issue is that companies, so research conducted at institutions, at least in the United States, is subject to, has to go through the IRB. There's certain regulations that the researcher has to comply with regards to protecting the human subjects, making sure that the risks of any research doesn't outweigh the benefits. So in the US, those regulations apply to research done at institutions, research using federal funding, and any company that really wants to have a medical device in the end and is working with the FDA. Those human subjects protection, the requirement to comply with those protections does not apply to private companies who are working on consumer products. And so there really is no oversight of the research that's being conducted. There's no mandatory oversight anyway of the research being conducted at those institutions or in that setting. I think that probably the bigger companies in this space are going to be good actors and want to comply and voluntarily go to IRBs, but there's nothing compelling them to. There's no regulation. So for me, that's another interesting issue. One more on the midterm point about the ethics is I do wonder how EEG or other neuroimaging data is going to be used in specific settings. So not necessarily for the general public, but in schools, in workplaces, in corporate settings. Are people going to be compelled to use them? What's a company going to do with the data? So if there's like, they've been, there's one company, I forget their name, Smart Cat maybe, that's been piloting the technology, I think, like amongst truck drivers in Australia. And so I'm not sure where they're at the moment, but right, how is that data? Like, let's say there's an accident, right? Mm-hmm. What's the liability issues with that data, and what's the EEG going to show, and how is that going to be interpreted, right? So specific contextual settings are another midterm concern. And then I think of the long-term concerns, right? These futuristic ones is privacy. And if these technologies do get better, can record really good data, what's it going to be able to reveal about us?
You kind of have to prioritize what are the first things that we're going to have to deal with, and then you can start thinking about what might come into play down the road, but that's a later issue. Some
people would disagree with that, and they say we need to be concerned about privacy now, which my colleagues would say that.
I guess you can be concerned with everything, but prioritize like what's the most pressing concern right now that we need to address, because I don't think maybe you can address them all at once, but I think it's difficult to.
Yeah, I just wanted to also, I guess, get your insight. One of the kind of main kind of interests we have with the technology is surrounds early detection. Again, kind of futuristically thinking that eventually we may all be coerced one way or another to wear these devices. Can these be used as some sort of biological neuro health passport, where if we have a baseline that spans many years, if we start I guess declining, or our EEG signals start changing, could those be kind of early detection tools for Parkinson's, Alzheimer's, brain tumors? So not exactly reading people's minds or trying to control objects, but just seeing if there is a degradation in the signal or change in the signal that maybe uses a biomarker. I don't know if you ever thought about the applications like that, and if they have any kind of some ethical limitations or some technical limitations that we should consider.
Yeah, I think it's a super interesting area, and I think that the ethical issues there are not dissimilar to early detection of disease by other methods. So actually, a colleague and I wrote a piece about the potential for direct-to-consumer Alzheimer's blood tests, because there's been some studies showing the potential of just basically showing Alzheimer's disease using the blood test. Or what if you can show brain changes in kids with autism and be able to diagnose autism earlier than expected? So, I think the issues there surround, at least the ethical issues surround the clinical utility of what you're doing. So is this early detection going to be useful for somebody? Are they going to be, is it going to provide, is it actionable in some way? Or is it just knowing earlier and you just know earlier, right? So I think that's going to be one of the key factors. In terms of brain biomarkers, so you have more experience with this than me. I'm not a clinician, but I think there's two things I've seen about the biomarkers. One is that there's been a lot of hope for biomarkers for a long time, and on the early studies that I saw, there was a lot of, and I'm talking more about psychiatric conditions than, let's say, detecting brain tumors or neurodegenerative diseases, so like depression or ADHD, biomarkers for that, let's say. There's been a lot of hope about this for a long time, and actually the early neuroethics literature actually spent a lot of time looking at potential for biomarkers, because neuroimaging was just coming up, and it was like, we're going to be able to diagnose things earlier because we'll have these biomarkers. And if you just take stock and look back, that the hopes haven't materialized, I think, as much as people expected back then. That's not to say it still can't happen. I just what people hoped back then hasn't necessarily come to fruition yet. That's just one point. And then the second point is something that Tom Inzel, who was the former head of the National Institute of Mental Health at the NIH here, he spent a while there, and he actually has been pretty vocal about, I don't know if regretting the efforts to find biomarkers has been the right word, but he's basically emphasized that, or he's questioned the value of putting all the research into biomarkers, especially again for these psychiatric conditions. So what value is it going to add to a patient if you're able to diagnose their ADHD with a biomarker? Are you helping the patient in some way? So I think this ties back to the utility question, or for depression, right? If there's other validated ways that get you there just as quickly, right? How much value is the biomarker adding? So the flip side to that is that you could tell me, you could probably think of several examples where actually early detection, like a brain tumor or something like that actually, would have very significant value. So for me, this falls on the clinical utility side, right? So is it a biomarker just for the sake of we got a biomarker, or is it a biomarker that has some actionable aspect to it?
Yeah, no, I think that's a very good point. And we've thought about the brain tumor space a lot, and there's some literature to suggest if you can potentially resect more of the brain tumor, people do better. Now, better is again a kind of a subjective term of what better means. Is that clinically or statistically significant? But that's kind of how we've conceptualized their potential value in brain tumors. Can you detect it early enough where a surgeon can do an aggressive surgery without debilitating the patient, and give kind of a meaningful extension? Obviously, that's very far into the future. That's not anywhere close to realization, at least the stuff that we're doing. I wonder if in the kind of these psychiatric disorders or mood disorders, if the true, I agree with everything you said. I think detecting depression a few months early may not be that relevant, but I wonder if you have, I know that there's some people that really struggle with finding kind of effective dosages and particular drugs that are really effective, and that could take many years.
Mhm.
And I wonder if we have these devices and can monitor their kind of brain activity, if we can titrate effective dosages once you're diagnosed. Can we have a biomarker that says, at this dose, the number of P300s that you experience in a day is meaningfully higher. So, that may be a good dose for you. Whereas in another patient, the same dose may not elicit a kind of a meaningful change in brain activity. And then you can use that as a kind of quicker way to titrate up or monitor progression in these diseases. So I agree.
Oh yeah, go ahead. Well, then that P300 would also have to be correlated with how good the person feels. Like if they subjectively feel it's also a meaningful improvement. Because if you just had the difference in the brain, but no subjective feeling of improvement, then.
Yeah, that's true. That's true. So there needs to be some correlation or between those two metrics. Do the brain waves make the patient feel better, or is it just a very subtle change that's electrically significant but not emotionally significant? So yeah, I think that's a very good point.
And the clinician's always going to err on the side of what's emotionally, like what's making the patient feel better, I would assume. But I think there is a lot of potential, right, to do that. So I'm like skeptical, but I also am hopeful at the same time that that recording this amount of data, having better signals, and again with machine learning and AI, right, there's a lot more that we can do, and that's like those capabilities, at least to the extent that they're used now, are relatively new-ish, right? Like the ability to analyze this much data and come up with all sorts of associations and correlations. So who knows? Maybe those it will be possible, and that would be great, right? Any improvement that we can make for patients and this sort of thing would be great.
But I think I know we're kind of running out of time here, but I think that there is need. Obviously, optimism is really important, but there is a need for skepticism. I always tell my students, I give my students the example of we do a lot of molecular profiling, and there's always new technologies that are more sensitive, more comprehensive. And you read a lot of these really high impact papers, and the conclusions they come to are very similar to what was kind of concluded many years ago using more kind of primitive techniques, albeit they could do it more comprehensively, and it's impressive from a kind of technological feat. But the biological conclusions sometimes don't meet the technological breakthroughs that you would expect. And I always give my students the example of a wheel. A wheel was the perfect shape for transportation many thousands of years ago, and we haven't really improved the wheel with any sophisticated calculus or machine learning that we've developed. So we're really looking for an airplane or a spaceship rather than a better car. Car seems to be kind of a highly evolved technology that is likely not going to improve. You can make it faster, but if you have stoplights and if you have pedestrians, the chances that a car is going to be meaningfully better with technology is very, very low, no matter how good that technology is. So I think there is a degree of skepticism and conservatism that needs to be applied to our expectations.
I'll also just add that it's also the case that often the things we can predict or we think are on the horizon are not the ones that actually end up changing our lives dramatically. So I don't know why CRISPR just came to mind and optogenetics, right? But like that wasn't totally foreseen, I don't know, years ago, and that's been like a really dramatic technology. So, or the iPhone.
Yeah. There's a good book I just read called The Black Swan. That really highlights there's no one expected that, when we think of a swan, it's white, and that was the definition of what a swan looks like. But once someone found the black swan, is a black swan a derivative of a normal swan, or is it a completely different species, right? So like you said, it's but the definition of a black swan from this author, we'll put the link of the book in the description, is that it has to be unpredictable. If you can predict it, then it's not truly it's not on the same distribution. A black swan is a different distribution that, like you said, it's like CRISPR. It's nothing that we could have logically predicted using the kind of scientific method. It's just kind of, we need to open our eyes and say, that's very different, and we couldn't have predicted it. And like you said, those are sometimes the innovations that truly transform the way things work. So
Yeah, I'll check that out.
Awesome. Well, thank you for joining us today, Anna.
Thank you. This is a very interesting conversation.
Yeah, I really appreciated all your insight into neuroethics, and just thanks for taking your time out of your day to join us. For anybody watching, if you want to check out the article that we touched on a little bit today, it's called The Skeptics Take on Neuralink and Other Consumer Neurotech, and it'll be linked down in our description as well. As always, thanks for watching. Make sure you like, comment, subscribe, and share with your friends. We'll see you next time on NeurosciQ.